Okay, in this section, we are in section 11.3. In section 11.3, we're going to look at studying solutions of quadratic equations. Now, coming out of sections 1 and 2 again, we learned about completing the square method. We learned about quadratic equation, two ways of solving quadratic equations. And in this section, we just want to know what's the nature and type of solutions to quadratic equation. So we don't really want to solve it. We could, but it's kind of a check. It gives us, after we finish our work in this section, we'll be able to know what kind of a solution should we expect out of a quadratic equation. So that's the objective of this section. Now, as you can see, we're in section 11.3 on page 715 of your textbook. It all begins with the idea of the discriminant, what you see in here, the discriminant of a quadratic equation. So let me go to my notes and we're going to start talking about this. So first, remember the general quadratic equation we're going to talk about is as follows. We have a x squared plus bx plus c equals 0. That's the form of the quadratic equation. Now, one of the attributes of this quadratic equation, one of the things that we can define is it's what's called the discriminant. So here I'm going to write discriminant. And what the discriminant of the quadratic equation is simply the radicand in the quadratic formula, the b squared minus 4ac. Now, because the a, b, c's are numbers, therefore the discriminant is going to be a number. Because a, b, c, again, these are numbers. Now, just as with any numbers, any number we think of, it's either positive, negative, or 0. We're talking about the real numbers here. So it's going to be one of those three numbers. Now, we're going to look at all the different situations, different scenarios that could happen, whether the discriminant is positive, negative, or 0. And what I'm about to write down for you, let me show you, is actually in the book. It's a page in the book. When I scroll down, there you go. This is the table that you see. And in here, you're looking at all that could happen to the discriminant. This is b squared minus 4ac. Could be 0, could be positive, or it could be negative. So I'm just going to reproduce this table in a different format, just to be different, but it's all the same information. So here's how I have kind of organized it for you. So right on top here, I'm just going to put b squared minus 4ac. Okay, so that's what that is. And I'm going to box this thing. So this is what the discriminant is. Now, the things that would happen here. Let me branch this off into 3 branches. Part of it here, and the other part's going to go clear over the other side. Now, over on this side, let's say here, I'm going to write down the type of solutions that this equation will have. So here is where the discriminant is actually, it's going to be less than 0. That means the discriminant is going to be negative. So if it's negative, then what's going to happen is the radicand becomes negative in the quadratic formula. And the result here, what we would expect is we expect 2 imaginary solutions. 2 imaginary. So that's what's going to happen when the discriminant is going to be negative. And in this case, the solutions, in the way of the solutions, we're going to have 2 complex conjugate solutions. So I'm going to write that, complex conjugates. That's what the 2 solutions will be. Now, if the quadratic equation has a discriminant that is 0, if the discriminant becomes 0, if it's equal to 0, then here is a case where we're going to have one rational solution one rational solution. And because all quadratic equations have two solutions, we're going to count this one rational solution twice. So we're going to call this a repeated solution. And I will explain why it's called repeated in another example, in a different example, repeated solution. And finally, when the discriminant is going to be positive, so here's a case now where the discriminant is positive. And for this one, we're going to actually have, this one has two cases of its own. So it's going to be first, depending on, because it's a positive number, so it depends whether this number is a perfect square or not. So I'm just going to write perfect square, and we're going to box this one. And the other possibility here would be, well, what if it's not a perfect square? That means it's going to be a non-perfect squared. So I'm going to put non-perfect square here. Okay, so we're going to look at both cases where the discriminant is positive. Now, I guess it begs the question, what do we mean by perfect squares? So let me just kind of note this on this, maybe below here. Perfect square numbers. Perfect square numbers. These are numbers. When you square a whole number, the resulting number is called perfect square. So the perfect square numbers are 0 squared 0, 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and so on. There you go. These are perfect square numbers. So if the discriminant, that's the radicand in the quadratic formula, if it's a perfect square, then in this case, the solutions are, we're going to have two rational solutions. Okay, and otherwise, if it's a non-perfect square, the discriminant that is, then we're going to have two irrational solutions. Okay, so there you go. We got two irrational solutions, and these solutions are going to be irrational conjugates. But the book talks about it, so I just mentioned it also. And there you have it. So this is pretty much what we want to know in this section. So again, to recap, depending on the discriminant, b squared minus 4ac, that's all we're doing here. We're not solving the equation. So here's b squared minus 4ac, depending on what this is. If this number is 0, let me read my red marker. If it's equal to 0, then this is what's going to happen. If it's less than 0, that means negative. Then this is what we would expect to see. And finally, for discriminant positive, we expect to see the following. We expect to see either two rational or two irrational solutions. And there you have it. This is a different way of illustrating what's in your book on that page. Now, let's take a look at some examples, shall we? So, first, for your homework, let me put down what your homework is. And what I'll do, I make sure on every video, I will actually go to the page of the book where the homework is, because I know some of you used to come forward and take a picture of the book because you haven't purchased the book. So I'll do that. I'll just make sure I display an image of the textbook, the homework problems. And then you can maybe take a screenshot and then just work through these exercises looking at the screenshots. Okay, so your homework here, I have you do numbers 7, 15, and 17. Okay, so let's take a look at, let me go to the page of the book now, and we'll show you these right in here. Now the homework is on page 718. So there we have space 718, enter. Okay, and once this loads, you're going to look at your homework. So I have you do again those three problems. The problem on page 718, and again, let me move this up for you so you can see it. This thing isn't cooperating with me. No problem. There you go. Maybe I can scroll it down. There you go. It's gonna work. And here it is. Feel free to take a screenshot or to use your cell phones, or however you know to do this. But the exercises you're going to be looking at are number 7 here. You're going to look at number 15 here. And you're going to do number 17 here. And of course, we usually go through the AHA problem. So feel free to take a look at that one. I guess the AHA on this one, I'm not sure what the aha moment would be, so maybe one of you can try it and let me know. Okay, so we're going to do numbers 8, this one, number 8, number 16, and number 18. Those are the ones we're going to take a look at. So let me go back to my notepad, and here we go. So in exercise number 8, here we go, in exercise number 8. This question asks, for each equation, determine what type of number the solutions are and how many solutions. So we want to know what type of solution and how many solutions. So exercise number 8, the expression is, let me go up. Okay, so the quadratic equation is x squared negative 5x plus 3 equals 0. Now, for the purpose of what we want to do, because we need to identify the ABC, so I went and I put a 1 in front of x squared, right in here. Right in here, put a 1, because we need to identify the ABCs. So, here we go. A is, let's see, what is A? 1. B is negative 5, and C a 3. Okay, so those are the A, B, and C. So let's do the discriminant. B squared minus 4AC equals. And for this one, let me, real quick, I'm trying to get a pad so I can kind of align my hand with the notepad here. Never mind what I'm doing. Okay, a little better. So B squared minus 4AC, that means it's going to be negative 5 squared. Negative 4 times A is 1 and C is 3. So the product's going to be negative 5 squared, 25 minus 12, and that's going to be 13. Now note, 13 is positive, right? So this is what the discriminant is, 13. Now this is a positive number, so if we go back up, if we go to, if we go up here, so remember 13, that would be a non-perfect square, right? Because 13 is not in this list, right? This is the list of perfect squares right in here. That's what this list is. Oops, sorry. Use my pen. There you have it. These are perfect square numbers. So 13 is not one of these, not one on this list. Therefore, we expect to have 2 irrational solutions. See, if it's a non-perfect square, we have 2 irrational solutions. So that's what I'm gonna write. So here we have. Oops, sorry, I didn't want to do that. Let me erase this one. Okay, so the answer to the problem is we have 2 irrational solutions. So 2 would be the number of solutions and irrational would be the type. Remember, they wanted the type and how many. And there you go. That's all we got to do here. Let's take a look at number 16. In number 16, the problem, the quadratic equation is x squared. Negative 2x plus 4 equals 0. So let's do our ABCs for this one. A is 1, B is negative 2, and C is 4. Okay, so that B squared minus 4AC is going to be, that's going to be a negative 2 squared. Negative 4A and C is 4. That makes it 4 minus 16, or a negative 12. Now, negative 12. Negative 12 is less than 0, right? It's a negative number. So it's going to be less than 0. Now, because it's less than 0, therefore, we're going to have two imaginary solutions. That's all again. Pretty simple, straightforward. Let's do one last one and we'll be done with this section. Number 18. In number 18, the equation is 10t squared negative t minus 2 equals 0. And our ABCs are A is 10, B is negative 1, and C is negative 2. So that B squared minus 4AC, our discriminant is negative 1 squared minus 4 times 10 times negative 2. That makes 1, and then here on the other side, negative times negative is positive. 4 by 10 by 2 makes 80. Right, that's going to be 80. So it's going to be 81. And 81 is the perfect square, correct? First of all, 81 is positive. Then if you go up here, we have a perfect square. If we have perfect square, 81 is in this list. So we're going to have two rational solutions out of this work. And that's what I'm going to write down. So in the way of solution, therefore, we have two rational solutions out of this work. And that's all we're doing in this section. So hopefully now you're able to understand what we mean by nature of solutions to quadratic equations. Okay, thank you, and I'll see you in the next lecture. That's all we want to do in this section.